Hi and welcome to day 2 of functions. Alright, today we are going to talk about function notation. So we see things in symbols and we need to know what they mean in words. If I have y equals x plus 5 written like that, in words it actually is y equals x plus 5. I can have f of x equals x plus 5. And in words, it means function f of x equals x plus 5. Then we have this other kind of notation. It's x with an arrow, a little x over the arrow, and x plus 5. And what this means in words is under function x, f, sorry, under function f, x changes to x plus 5. Fourth kind of notation is f colon x arrow x plus 5. And that has the same words as number 3 under function f, x changes to x plus 5. And finally, number 5 is f equals a bracket, parentheses, x plus y, and a straight line up and down, y equals x plus 5, close the brackets. And in words, that means function f is the set of ordered pairs x, y such that y equals x plus 5. So what I have there is 5 different ways to write the same thing. 1 and 2 is mostly where we concentrate our efforts this year. And basically when you compare the two, you can see that f of x has to be equal to y, because if you were set them equal to each other, they would both be equal to x plus y, or x plus 5, so f of x is equal to y. That's very important to know and understand. We're going to use them interchangeably all year long. So applying function notation. If y equals negative x squared and x equals negative 5, find y. Well, y is equal to negative for x, and I end up with a negative, and then the negative y squared is 25, so negative 25. So, in other words, this is like saying the point over 5, negative 25. So I can write my answer as an ordered pair. I don't have to, but I can. Just y is equal to negative 25. For number 2, g of x equals negative x squared. Find g of negative 4. So what that means is I'm going to substitute negative 4 in for x. So g of negative 4 equals a negative 4 squared. So I have a negative, and then negative 4 squared is 16, so I have negative 16. So g of negative 4 is equal to negative 16. I do not divide by that negative 4. That is not negative 4 times g. It's just function notation. So my ordered pair here would be negative 4, negative 16. If f of x equals 2x over 3, find f of 6. So that means I'm going to take 6 and put it in place of x. So f of 6 is equal to 2 times 6 divided by 3. Well, 2 times 6 is 12, divided by 3 is 4. So f of 6 is equal to 4. If I were to write this as an ordered pair, it would be 6, 4. For number 4, I have under function p, x changes to the square root of x. So we have to find p of 16. So I'm going to substitute in 16 in place of x. So the square root of 16 is 4. So this will be 16, comma 4. The only reason I'm writing in ordered pairs is because I want you to see that what you substitute in is you're putting in place of x, and your answer ends up being y in the ordered pair. So no matter how funky your notation is, it's still just an ordered pair of x and y. So we have under function h, x changes to 1/3 of x. So find h of 1/2. So I'm going to put in 1/2 in place of x. So we have 1/3 times 1/2, which is 1/6. So my ordered pair is 1/2, 1/6. Remember, when you multiply fractions, you simply just multiply numerators, multiply denominators. For number 6, got that real crazy notation. With all that craziness, the only thing you're really doing is just taking 12 and putting it in place of x. So we'll have f of 12 is equal to y, which is equal to 12 minus 3 over 9 minus 12. So 12 minus 3 is 9. 3 minus 12 is negative 3. 9 divided by negative 3 is still a negative 3. So my ordered pair here is 12, negative 3. For number 7, if the domain of g is 2, 4, and 6, and g is the function x, negative x plus 2, find the range. Well, if I'm given the domain is x, to find the range is y, I'm just going to take x and substitute in and find y. So I'm going to have to substitute in for 2. So I substitute for 2 out negative 2 plus 2. So my answer is 0. When I put 4, I will have negative 4 plus 2. So I have negative 2. And when I put in 6, I'll have negative 6 plus 2. And that'll give me negative 4. So my range is all my y values are my answers here. In this case, I have 0, negative 2, and negative 4. For number 8, last one. If given the graph of function k, find k of 1, k of 2, k of 0. So what it's asking for is I'm giving you the x value, and you need to tell me the y value. So looking at the graph, if x is 1, my y value is also 1, because that's the point 1, 1 on your graph. If x is 2, my y value is 1, 2, 3, 4. So that would give me the point 2, 4 on the graph. If k is 0, well, my x value is also 0. So I would have the point 0, 0. So what we're doing here is we're just using our x values, and that is my domain. And my answer is are my y values, and that is my range. And that's how number 7 and number 8 are alike. 1 using just algebraic function, and 2, number 8, they're using a graph to find the same things. So I'm giving you the x value on number 8, and you're finding the y value at that x value. All right, see you tomorrow.